Hello friends, I am Aditya Patil from BK Birla College Physics Department. Today we are going to talk regarding microprocessor. Microprocessor is a basic function of a computer, calculator, mobile and anything electronic device that we use regularly. Introduction. Microprocessor is basically a computer processor that incorporates the function of a central processing unit on a single integrated circuit, or sometimes up to 8 integrated circuit. The microprocessor is a multi-purpose clock driven register based digital integrated circuit that accepts binary data as input and processes the data and gives output as per our requirement. It also stores the data inside it, which is used later. Sir, microprocessor accepts instructions stored in memory and provides result as a output. Microprocessor contains both combinational logic and sequential digital logic. Microprocessor operates on number and symbols represented in binary number system. The integration of the whole CPU onto a single or few integrated circuits greatly reduces the cost of processing power. The integrated circuits processors are produced in large number by highly automated metal oxide conductors. MOS fabrication processes, resulting in a low price single chip processor increases reliability because there are many fewer electrical connections that could fail. Microprocessor designs improves the cost of manufacturing of a chip. Smaller components built on semiconductor chip the same size generally stays the same according to Rock's law. Before microprocessor, small computers had been built using a rack of a circuit boards with many medium and small scale integrated circuits. The microprocessor combined these into one or few large scale ICs. Continued computers almost completely obsolete. Okay, smallest embedded systems and handle devices to largest mainframe computers. History. Talking regarding history of microprocessor was invented in 1971. The first microprocessor Intel 4004 was invented. Microprocessor is also known as a central processing unit in which numbers of peripherals are fabricated on a single chip. It is also ALU, or we can say at arithmetic and logic unit, a control unit, registers, bus systems and a clock to perform the computational tasks. Invention. Who invented microprocessor? Microprocessor was invented by scientist Gordon Moore in 1968. Gordon Moore were working for Fairchild Semiconductor Company, who decided to quit and create their own company at the time. A young scientist Tenhoff at Intel was assigned to work with the mini computers, and in June 1968 he was asked to join the group of Japanese engineers, and thus in this way microprocessor journey started. Introduction. Here we are going to talk regarding the basic model of microprocessor, that is 8085 microprocessor. What is it? 8085 microprocessor is a semiconductor device integrated circuit manufactured by VSL, very large scale integration technique. It includes arithmetic and logic unit, registers and control circuit on a single chip to perform functions or useful tasks. We can connect memory and other add-ons like keyboard, logic circuit, etc. to the microprocessor. Microprocessor commands the devices according to the program or code which is written or stored in it inside microprocessor. There is a central processing unit, semiconductor memories like RAM, ROM, etc., input output device and integrating devices. Memories, input output devices and interfacing devices are called peripherals. The popular input devices are keyboard and floppy disk, and output devices are printer, LED, LCD displays, CRT monitors, printers, etc. Advantages of microprocessor based on systems. Computational and professional speed is high, intelligence has been broad systems, automation of industrial and office administration. Since the devices are programmable, there is a computer the system by changing the software alone. Also, it is more reliable. Operation and maintenance are easy. It has a compact size and its cost is also less. Feature of 8085 microprocessor. 8085 microprocessor is a 8-bit microprocessor. Each character is represented by 8-bit or 1 byte. It is manufactured by NMS or N-type metal oxide semiconductor technology implemented with 6000 transistor. It has a 16-bit address lines. Hence, we can point up to 2 raised to 16, that is 65,535 bytes, 64 KB memory location. The first 8 lines of address bus, 8 lines of data bus are multiplexed, and ADO AD7 data bus is group of 8 lines. AD087, it is purpose register arranged in pairs, BC, DE, HL and 2 special purpose register. It consists of 74 control lines. On chip clock generator, it requires a single plus 5 power supply and operates at 3.2 mega single phase clock with maximum clock frequency of 6 megahertz and minimum clock frequency of 500 kilohertz. The serial output port 1.3 microsecond instruction cycle. It enclosed with 40 pins and 3 chip microcomputers, etc. Architecture. The internal architecture of 8085 includes arithmetic logic unit, timing and control unit, instruction registers and decoders. Registers array, interpret, control and serial I/O controls. The main heart of microprocessor is CPU. CPU, central processing unit, comprises of arithmetic logic unit, timing control and instruction register, decoder, register array, interrupt control, serial I/O control. It is a multi-operational combinational logic circuit, same as IC 74181. It performs arithmetic logical operation like ANDing, ORing, XORing, etc. Addition, subtraction, etc. It is not accessible by users. The word length of arithmetic logic unit depends upon the internal data bus. It is 8-bit. It always controlled by timing and control circuits. It provides status of result of on flag register. Figure shows below the function section of arithmetical logic unit. Here we can see the basic block diagram of microprocessor 8085. It is the internal structure, and here we can see the control, ALU, timing control sections, address bus and etc. All the connections are shown in this circuit diagram. Arithmetic and logic section of blocks. Adder. First is adder. Adder performs arithmetic operations like addition, subtraction, increment, decrement, etc. The result operation is stored into accumulator. Second, shifter. Shifter performs logical operations like rotate left, rotate right, etc. The result of the operation is again stored in accumulator. Third is status register. Status register, also known as flag register, it contains a number of flags either to indicate the condition arising after last arithmetic logical operation or to control certain operation. Fourth, accumulator. Accumulator is one of the general purpose register of microprocessor, also called A register. It is a 8-bit register that is a part of arithmetic and logical unit. This register is used to store 8-bit data to perform the arithmetic and logical operation. The result of the operation is stored in accumulator. The users can access this register by giving appropriate instruction and commands. The next one is temporary register. Temporary register is also called as operand register. It provides operands to arithmetic logic unit. Arithmetic and logical unit can store the immediate result in temporary register. It is not accessible by user. Status or flag register. Flag register is a group of flip-flops used to give status of different operation result. The flag register, once a operation is performed by arithmetic logical unit, the result is transferred on internal data bus and status bus will be stored in flip-flops. There are called zero, carry, sign, parity and auxiliary carry flags, etc. Types of flag. The first type of flag is a carry flag. Carry flag, if an operation performed in arithmetic logical unit or ALU generates the carry from D7 to next stage, then CY carry flag is set, else it is reset. Second is auxiliary carry flag. If an operation performed in arithmetical logical unit generates the carry from lower nibble D0 to D3 to upper nibble D4 to D7, AC flag is set, else it is reset. Zero flag. Third is zero flag. Zero flag, if an operation performed in arithmetical logic unit results over zero value of an entire 8 bits, then the zero flag is set, otherwise it is reset. Fourth is sign flag. If the number is positive, if MSB bit is 0, then the number is positive, else it is negative. That means for 0 it is positive and 1 is negative. Parity flag. Fifth is parity flag. If the result contains even number, once this flag is set, and for odd numbers the flag is reset. Types of registers. There are types of registers. First one is temporary register. The temporary register can only be accessed by microprocessor and it completely inaccessible to programs. Temporary register is a 8-bit register. This register is used by control system to hold operands, intermediate operands and address of memory IO devices temporarily. General purpose registers. Apart from accumulator 8085 consist of 6 special types of register called general purpose register. These general purpose registers are used to hold data like any other register. The general purpose register 80H by processor are B, C, D, E, H, L. Each register can hold 8-bit data and the combination can be used to store 16-bit register. Third one we go special purpose register. It is first in each program counter. Program counter is a special purpose register. Consider that the instruction is being executed by processor. As soon as the arithmetic logical unit finished executing the instruction, the processor looks for the next instruction to be executed. So there is necessary for holding the address of next instruction to be executed in order to save time. This is taken by a program counter. Program counter stores the address of next instruction to be executed. Microprocessor increments the program whenever the instruction is given executed so that the program counter points to the memory address of the next instruction that is going to be executed. Program counter is 1. Pointer. Stack pointer. Stack pointer is also 16-bit register which is used as a memory pointer. A stack is nothing but a portion of random access memory. Stack pointer maintains the address of last byte that is entered into stack. Each time when the data is loaded into stack pointer gets decremented. Conversely, it is incremented that data is retrieved. Then further, it is increment and decrement register. The 8-bit contents of register of a memory location can be incremented or decremented by 1. This 16-bit register is used to increment or decrement the content of a program counter and stack pointer register by 1. Increment or decrement can be performed on any register or memory location. Next one is address and data buffer and address buffer. The contents of the stack pointer and program counter are loaded into the address buffer and the address data buffer. These buffers are then used to drive an external address bus and address data bus. As the memory and IO chips are connection to these buffers, the CPU can exchange desired data into memory. The address data buffer can both send and receive data from internal data bus. They are connected to external data bus but also to internal data bus, which consists of 8 bits. Instruction and register decoders. Instruction register is a 8-bit register just like every other register of microprocessor. The instruction may be anything just like adding two numbers, moving data, copyright, etc. When such instruction is fetched from memory, it is directed to instruction register. So the instruction registers are specifically to store the instruction that are fetched from memory. There is an instruction decoder which decodes the information and present it in the instruction register for further processing. Timing and control unit. Timing and control unit is a very important unit as it synchronizes the registers and flows data through various registers and other units. This unit consists of oscillators, control sequencer, which send control signals needed for internal and external control of data and other units. The oscillator generates two-phase clock signal which aids in synchronizing all the registers of 8085. Signals that are associated with timing and control unit are shown below. There are control signals, status signals, DMA signals, reset signals. Procedure. Basically, microprocessors are used to carry out various functions or programs. In order to carry out various functions and programs on microprocessor, first we have to click on reset, then examine memory, then we have to input the first memory location, and then by clicking on the next button we will have to enter the whole opcode that is given in the opcode sheet and then press fill. Second step, again we have to press reset, then we have to press go, and again we have to enter the first memory location and then press fill, then E will come. Then third step, we will have to reset, then examine memory, then we have to type the last location where the result is being to be stored, and next. For example, memory location where the result is stored can be more than 1 byte. For example, if result is numerical digit 3628, which is approximately, we can say that 36,28,200. In microprocessor language, 36,28,800 can be written as 375F00. So 375F00 is a 3-bit and then it is stored in 3 different memory locations. Please like and subscribe the video. We will further discuss on programs carried in next video on microprocessor. Thank you for watching. Bye.